Hello students, today we will see the remaining portion of the extraction of metals. Last class we have discussed what is an ore and what is a gangue. What is an ore? Ore means it is the mineral which contains a higher percentage of metal which can be extracted profitably. That is a value point. Which can be extracted profitably. Profitably means what? Cheaply or easily. Okay, so that is called as an ore. And what is gangue? Gangue means the impurity present in the ore is called as the gangue, isn't it? The impurities present in the ore is called as the gangue. So we studied what is an ore and what is a gangue. Okay, so today we will study how you will extract the metal from an ore. Now we got the ore, and last class I have told you that ore are mainly in the form of oxides, then sulfides, then carbonates, etc. We found normally in the earth crust as sulfides, for example iron sulfide or copper pyrites. Copper pyrites means what? CuFeS2, that is again a sulfide ore. So normally we see the ores in oxides. Why in oxides? Oxides means, you know, oxygen is very reactive metal, isn't it? That reactive element. So this oxygen can be what? React with almost all the metals to form its corresponding oxides. And besides oxides, sulfide ores are there or carbonate ores are there, etc. Okay, and we have seen the reactivity series, isn't it? That is sodium, potassium, etc. up to the noble gas, the noble elements. Okay, there we have studied that some are more highly reactive metals, some are moderately reactive metal, and some are least reactive metal. Okay. So now we will see how we will extract the metal or how we will get a 99.9% pure metal from an ore. Okay. So mainly there are 5 steps in this extraction of metals. That is, the first step is crushing of the ore. What do you mean crushing? Crushing means the ore we will get from the earth crust is what? It will be a big one. Okay, so we have to break down into smaller pieces. That is crushing, you know, crushing. Okay, so break down into smaller pieces. The big pieces, that is cut or broken down into smaller pieces. That is the first step. So we have to crush the ore into smaller particles or smaller things. Okay, so that is the first step. That is crushing of ore. Okay. Now what is the second step? Second step is very important. That is concentration of the ore. Okay. What do you mean by concentration of ore? As I told you, the ore comes along with impurities, many impurities like what? Sand or clay or rocks, etc. Now what we have to do? Before going into extraction, we have to remove the impurities present in the ore. That is, you have to make the concentration of the ore more by removing the impurities. What are impurities called? Impurities are called as gangue. Okay, so second method is or second step is concentration of the ore. In fact, this is the first step of the purification of metal, isn't it? That is, here we are removing the impurities to a larger extent. That is, we are removing the impurities like clay or sand or rock, etc. in this stage or in this step. So this is called as an initial purification step. If you want to say, we can say it is an initial purification step. Okay. Or this concentration of ore is also called as dressing of ore. Okay. In some textbook you can see dressing of ore. So concentration of ore can be also say as dressing of ore. That means you have to take away the impurities from the ore and make the metal more. That is called as concentration of the ore. Clear? First was crushing of the ore. You made it into smaller particles. Then second is the concentration of the ore. You made the concentration of the metal more by removing the impurities or the gangue particles. Okay. Now what about the third step? Third step is conversion of ore to oxide. Okay. Now let me tell you, these two processes are not given in your textbook. Okay. Now only from the third part in the textbook they are given. Okay. But I will just say, or I will just give an idea of how to concentrate an ore, just to give an idea how this ore is concentrated. Okay, we can concentrate the ore by the difference in the physical or chemical properties of the ore as well as the gangue. What do you mean by that? You know, ore has some physical properties, or the gangue has some another physical properties. So depending upon these physical or chemical properties, we can separate or we can remove the ore from the, remove the gangue or the impurities from the ore. If I say one example, the first example we can say is the gravity separation. What do you mean gravity separation? Let me say, if the ore is a heavier particle than the gangue or the impurity, we can separate this ore and gangue by means of gravity separation or hydraulic washing that we will study in 12th standard. Just to have an information of this, how what are the different methods by which we can concentrate the ore, that's all. That is simply by means of hydraulic washing. If you give a stream of water in force or pressure, the lighter particles will come down and the heavier particles will be there. That is, there is some grooves in that this thing. So the ore or whichever is the heavier particle, that will be in the groove, and the lighter particle will come as we wash the impurities. So that you will study later. So the first is hydraulic washing. Now, a second method for concentration of ore is if an ore or a gangue means impurity, if one of this is having some magnetic properties. What do you mean magnetic properties? It will attract the magnet, isn't it? So if either the ore or the gangue has got a magnetic property, then we can have magnetic separation. Okay, we will have a belt and then we will put this ore plus gangue. Then if it comes into the belt, the magnetic property, if the ore is having magnetic property, it will come with this. So that we will study later. So second is a magnetic separation. First was a hydraulic washing. And third one is froth flotation process. Just for information, that is, if an ore is a sulfide ore. Sulfide ore means what? Something like FeS or Cu2S, like that. If some sulfide ores are present, we can concentrate the ore by means of froth flotation process. Okay, froth flotation process. Okay, so that is froth flotation process. Okay, so these are some of the different methods by which you can concentrate the ore. Again, there are chemical methods like leaching. Okay, that is the extraction of aluminium from bauxite. Okay, these you study in higher classes. So just to have a kick of that, there are several methods for the concentration of ore or dressing of the ore, like gravity separation, then froth flotation process for sulfides, then magnetic separation for the separation of the iron ores that is magnetic, then chemical methods like leaching, etc. Okay, just for information. Okay, now from this conversion, the third step in your textbook, it is given in detail. Okay, now we got it. What is concentration of ore? Okay, and now what is crushing of ore? Okay, now we will pass on to the conversion of ore to oxide. How will you convert? Now you have ore in hand, and that ore is impurity free, not 100%, but a 70% impurity is free. We can wash it or we can magnetic separate it so that the gangue is separated somewhat from the ore. But still it is having impurity. Okay. Now that we will have that later, the process like purification. Now what we have to do is, the third step, the conversion of ore to oxide. Why we want to convert the ore into oxide? Why? Why? Because in the case of an oxide ore, it is easy to extract the metal from the oxide ore. Remember, it is always easy to extract a metal from the oxide ore. It's very, very important. If once the ore is in its oxide form, you can extract the oxide into metal. It's very, very easy. But if it is sulfide ore, what you will do? If it is a sulfide ore, first thing is you would convert the sulfide ore into the oxide ore. That is it. So that is the thing. So if you have in detail about the conversion of ore, to the oxide ore. This is important. Okay. Normally, other than oxide ore, if it is an oxide ore, well, you can have this conversion of the oxide ore to the metal by reduction. Okay, but if it is not an oxide ore, there is a possibility of two kinds of ores normally. One is sulfide ore and second is carbonate ore. These are the two ores which you generally come across while you are having this extraction process. That is, one is sulfide ore. Okay. One is sulfide ore and the other is the carbonate ore. Okay. These are the two types of ores which you normally come across in the extraction of metals. Now what you have to do? You have to convert the sulfide ore into what? Into oxide ore. Isn't it? You have to convert the sulfide ore into oxide ore as well as the carbonate ore into oxide ore. So why the oxide ore is very important? Why? Because if oxide ore is there, it is very easy to reduce to the corresponding metal by reduction. That is why the oxide ore is preferred. Understood? Okay. Now the question is, how you will convert the sulfide ore into oxide ore? How you will convert the sulfide ore into oxide ore? So the process of the conversion of a sulfide ore into the oxide ore is called as roasting. Very, very important. It is called as roasting. So what is roasting? Roasting means the conversion of a sulfide ore into its oxide ore in presence of excess air. That is the value point. That is the conversion of the sulfide ore into the oxide ore in presence of excess air. That means we have to give oxygen and heat it. Then what happens? The sulfide ore is being converted to what? The oxide ore. So is it clear? Now if you want an example, I can write HGS. Simple example, that is mercuric sulfide. What do you mean by roasting? It is a sulfide ore, correct? Now what you have to do? You have to roast it. You know, roasting means what? You have to keep on the flame for long, isn't it? That is why we call it as roasting. The same thing is applicable here also. In the presence of excess of air, if you heat, the sulfide ore is converted into the corresponding oxide ore, correct? Now we will say O2, that is what? Why O2? Because you are giving air or oxygen. In presence of excess air or oxygen, if you heat, how will you say heat? You have given, either you have to write heat or you have to give a triangle. Okay, so then we will get what? We will get the corresponding oxide. See, the mercuric sulfide is being converted into the mercuric oxide. Clear? So, if our ore is a sulfide ore, what you have to do? You have to convert. See the second, third step? Conversion of the ore into oxide. So, if you are having a sulfide ore, what you have to do? You have to convert the sulfide ore into the oxide ore by means of what? Roasting. And what is roasting, by the way? It is the process of the conversion of a sulfide ore into an oxide ore in presence of excess air. That's the value point. Two value points, heating and in presence of excess air. That is example HGS, it's a sulfide ore, it is called as cinnabar, you will study it later. Plus oxygen, you are giving oxygen. In presence of excess of air or oxygen, you are strongly heating, see? Then you will get the corresponding oxide. Now once you get the oxide ore, then it is very easy to convert this oxide ore into the metal. That is the fourth step. Okay. Now that is okay. Sulphide ore, we converted it into oxide ore. Now what about the carbonate ore? How will they convert the carbonate ore into the oxide ore? Carbonate ore can be converted into an oxide ore by means of another reaction which is called as calcination. What is it? Calcination. What is the process by which a sulphide ore can be converted into oxide ore? Roasting. Now what is the process by which a carbonate ore can be converted into oxide ore? Calcination. How will you remember? C for C. Carbonate ore, calcination. Sulphide ore, yes, sulphide. Roasting, yes. So S and S. See? Just I am telling you just how to remember, that's all. It is your this thing. You can have anything like I remember like this: carbonate CC, carbonate ore, calcination. Roasting, S having like this thing, so sulphide ore. Okay. You can find your own way, whatever way you want, you can have that, no problem. Okay, now what is calcination? Calcination means it is the process of converting a carbonate ore, that is we have a carbonate ore, so you have to convert the carbonate ore into an oxide ore. So the conversion of a carbonate ore into an oxide ore in presence of less amount of air, that is the difference. This is strong heating in presence of air. This is also heating in limited supply of air. That is the value point. What is the value point? Limited supply of air. So, if the value point is limited supply, here also what? Here also you are heating. Carbonate means, calcination means it is also heating, but in a limited supply of air. For example, if I say a carbonate ore, zinc carbonate, see, zinc carbonate, I am only giving heating, I am not giving oxygen. That is the difference. You understood? In the sulphide ore, what you have done, see, in the sulphide ore, HgS plus O2, I have given excess air and strong heating. That is the difference. Calcination means what? There is no excess air because already there is oxygen here. Correct. So, only in a limited supply of air, if you heat it, this carbonate ore is being converted to what? Into the corresponding oxide ore. That means zinc oxide plus carbon dioxide. See, this is the main difference between the calcination as well as roasting. Board exam, it can come. What is or write an equation where calcination is there, or how you can convert a sulphide ore into an oxide ore, or why you want to make this sulphide ore or the carbonate ore to an oxide ore. Now, why the oxide ore is being preferred for the reduction process? So, all these questions can come. You know that, isn't it? So, what is roasting? Roasting is the process of conversion of a sulphide ore into an oxide ore. Right? Strong heating in excess of air. Two value points. One is strong heating and second value point is in excess of air. Now, what is calcination? Calcination is the conversion of a carbonate ore into an oxide ore. Now, how will you define calcination? Calcination is the process of heating of a carbonate ore in a limited supply. The two value points are, again there is a strong heat, but in a limited supply of air to convert into an oxide ore. Got it? Clear about roasting and calcination? Okay. Now we will move on to the fourth step, which is also very, very important. Okay, first step was the crushing of the ore. You know, we are broken down into smaller pieces. Second is the concentration of ore or the dressing of ore. We can call it as an initial purification, isn't it? So, that is the concentration of ore. That we have many steps I have told you. That is hydraulic washing or gravity separation. Then second is the fourth flotation process. Third is the magnetic separation or chemical methods such as leaching, etc. That you don't worry, don't have in the syllabus. Just I told you for the information. Okay. Now, we have seen the third step, that is a conversion of ore into oxide, which is the very important step in all the 5 steps. Okay, that is the conversion of ore into an oxide. 2 types. If it is an oxide ore, well and good. But if normally I told you the ores are of sulfides as well as carbonates, oxides are also there. Definitely oxides are there. For example, in the case of iron, you are getting directly the magnetite and hematite, Fe2O3 and Fe3O4. That is okay. But if in case the ore is a sulfide ore or it is a carbonate ore, what you have to do? You have to first convert these 2 ore into the corresponding oxide ore. Clear? Very, very important. Now, from sulfide ore to the oxide ore, what is the process? Roasting. What are the 2 valley points? One is strong heating and second valley point is excess of air, because we are giving oxygen, isn't it? When you are writing the chemical equation, you have to write plus O2. Now, what is calcination? Calcination is the process of conversion of a carbonate ore into its respective oxide ore. Now, what is the valley point there? It is also a strong heating, but in a limited supply of air. That's the valley point. So, now we got the oxide ore. Is it clear? Okay. Now, we will pass on to the 4th step, that is the reduction of oxide ore to metal. Now you know we are getting, first what we have this ore with gangue, isn't it? Gangue means the impurity. Now what we have done, we have crushed it. Second, what we have done, we have taken away the impurities like silica. Silica means sand, rock, clay, etc. There we have done the initial purification. Now third, what we have done, we have converted this ore into its oxide, isn't it? Now the 4th step is, that's also very important, the reduction of this oxide ore into metal. Here we are getting the metal in the first phase. Second phase, purification of metal, that is 99.9% pure metal is getting in the 5th phase. But in the 4th phase, we are getting the metal having slight impurities. Okay. Now we will see what is happening in the reduction of the oxide ore to a metal. Okay. Here, I will say something more about this reduction. Okay. That is, I have told you, the 4th step is a reduction of oxide ore to metal. Now we can say just oxide, right? The reduction of this oxide to metal. Now see, what do you mean by a reduction? You know, we have studied in the first chapter about this oxidation and reduction, isn't it? So what is reduction? You know, addition of hydrogen or removal of oxygen. Now in this case, what is happening is the reduction of oxide to a metal is taking place in presence of a reducing agent. What is it? In presence of a reducing agent. Okay. What is this reducing agent? Now I will talk something about this reducing agent, and after that we will go for this reduction of this oxide into metal. Okay. In the first chapter, we studied about this redox reaction in which the oxidation as well as the reduction takes place simultaneously. We called that reaction to be a redox reaction. Do you remember that? Okay. If you are not remembering, I will once again I will write that reaction. For example, you have studied the reaction as copper oxide, right? CuO plus hydrogen will give you Cu plus H2O. You are remembering this reaction? It's a redox reaction. Listen carefully. Here, I want to talk about reducing agent and oxidizing agent. Okay. So, here what happens? What is getting oxidized and what is getting reduced? That you know. Isn't it? See here, oxygen is removed. Oxygen is removed means what? That is reduction, isn't it? Loss of oxygen. So here I can write reduction happens. Correct? Because loss of oxygen. See? CuO is being converted to Cu, which means what? There is a reduction happening here. Okay. Now what happens to H2? H2 is gaining oxygen. What is gaining oxygen? Oxidation. So here hydrogen is being oxidized, isn't it? Or adding of oxygen. You have this studied in first chapter. Just once again I am recapping it. Okay. Now, You know this much. Here, if I ask you, what is getting reduced means, you will tell me copper oxide is being reduced to copper. Exactly. Now, what is getting oxidized? You will tell me hydrogen is getting oxidized to water. That's also right. Now, what is the reducing agent and what is the oxidizing agent in this reaction? That is the question. What is the reducing agent or what is the oxidizing agent? I will tell you very simply that something is reduced. Listen carefully. This is the best way to remember. I will tell you why. Okay, the reason behind it I will tell you. The something which getting reduced is the oxidizing agent. That is the reverse of that. Listen, something which is reduced is called as oxidizing. Reduction means opposite oxidation. So, oxidizing agent. Listen. So, this is reduction. So, I will say CuO is the oxidizing agent. You got the point? You know this is the reduction happening, correct? Now, where is the reduction happening? That thing is called as, or that compound is called as oxidizing agent. Reverse. Agent means reverse. Reduction happens, oxidizing agent. Now, here it is oxidation happens, then which agent? Yes, exactly. What is it? Reducing agent. So, here I will say it is the reducing agent. See, it's a very simple way to remember. Which is getting reduced? That is oxidizing agent. Which is getting oxidized? That is reducing agent. Now, I will tell you the chemistry behind it. See, what do you mean by oxidizing agent? What do you mean agent? Agent means somebody who is helping us, isn't it? Is helping. So, oxidizing agent means this compound helps in oxidation, isn't it? What do you mean by helps in oxidation? For oxidation, you have to give oxygen, correct? So, here it is having oxygen in it, copper oxide. So, it is ready to give oxygen, isn't it? So, it is ready for giving oxygen to something else. So, that is why we called it as oxidizing agent, which helps in oxidation. Because it is having oxygen, it is ready to give oxygen. That is why it is called as an oxidizing agent. Do you get it? Clear? Understood? Okay. Now coming back to reducing agent. What is reducing agent? Something helps in reduction. Reducing. Opposite of it. That is, if hydrogen is getting oxidized, we can call hydrogen as what? A reducing agent. Opposite of that. So, is it clear? So, now you know what is oxidizing agent and reducing agent. Okay. If you are not clear, just tell me, call me, I will make it more clear. Okay. Now, coming to the fourth. Okay. Now, coming to the fourth step, that is the reduction of oxide to metal. See, the reduction of oxide to metal is also very important by using suitable reducing agents. Now, you know what is reducing agent? Something helps in reduction. Something is taking away the oxygen that you want. Yes, some element which helps in taking the oxygen from the compound is called as reducing agent. Okay, I will give you an example for that. For example, mainly we are using reducing agents like carbon. You know carbon black, or carbon monoxide, or hydrogen, etc. These are the examples of what? Reducing agents. See, sorry. These are the examples of what? Reducing agents. Carbon monoxide, then hydrogen, etc. are the examples of reducing agents. Now, what this will do? We have oxide in your hand, right? See, a simple example, you have zinc oxide. You have zinc oxide. Now, what you will do? You reduce it with carbon. See, carbon is a reducing agent, isn't it? So, you reduce it with carbon, you will get the metal zinc plus carbon monoxide. See, this is how the zinc oxide, the conversion of the oxide into metal. Got it? That is, the zinc oxide, when you treat it with carbon, you will get what? Zn plus CO. Or if you want the CO, if you use carbon monoxide, that is also a very good reducing agent. What will happen? You will get Zn plus carbon dioxide. So these two are the reducing agent. Hope you understood clearly what is reducing agent as well as oxidizing agent. Why you call carbon as reducing agent? It helps in reduction. Reduction means what? Reduction means pulling the oxygen, taking the oxygen, removal of oxygen. This carbon helps in removing the oxygen of this zinc oxide to zinc. That is why the carbon is called as a reducing agent. And itself getting oxidized. See, carbon, the reducing agent itself is getting oxidized to what? Carbon monoxide or carbon dioxide. So that is the fourth step, that is the reduction of this oxide ore into metal. Clear? Hope you understood very clearly about this reducing agent as well as the oxidizing agent. Okay. Now we will see the last step, that is the purification of metal. Now we have metal in our hand. From where? The first step, crushing, concentrating or dressing, then reduction of this ore to the oxide, then oxide to the metal. Now we have metal. But you know, this metal also contains impurities. Small impurities. Now what you want? You want a 99.9% pure metal. Now how can you bring or how can you convert this metal into a very pure metal? That is the fifth step, that is the purification of metals. Okay, now we got this fourth step, that is the reduction of oxide to metal, reducing agent, oxidizing agent. Clear? Okay. Now this is the easy one, that is the purification. The purification of the fifth step or the last step is the purification of metal. How will you purify this metal? Now you have got this metal. Okay. Now normally the purification is done by electrolytically. This step you have already studied in 8th standard or something. Purification of copper, purification of gold, purification of silver, mercury, nickel. All these metals can be 70% of these metals can be purified by means of electrolysis or electrolytically by giving electricity. Okay, so by means of electrolysis, or you call it as electrolytic refining of copper. Okay, so that is the fifth step, that is the purification of metal. How you purify? That we will study later when you come across with all this once again. Okay, so you got this 5 steps. What are the 5 steps? Crushing of the ore is the first step. Second step is the concentration of ore or the dressing of ore. Third step, the conversion of metal oxide. Fourth step, the reduction of this metal oxide to what? Metal. And the fifth step or the last step is the purification. So you got that? Okay. Now I will give a table which you are given in your textbook. That a small flow chart, I mean to say flow chart regarding the extraction of the metal. Okay, just I will draw it. Okay, just see it. You refer to your textbook, you can have that. First, the ore is there. Okay, ore is there. Now, here what you have to do, you have to concentrate the ore. Okay, or simply I write it as concentration of ore. You don't have to study the detail. You will come to 10th standard, you will study all this, okay, one by one. So just you write the concentration of ore. Okay, just leave how you concentrate it. Okay, then we can have 3 divisions of this classification of metals. One is metals of high reactivity. Metals of high reactivity. You know which are the metals of high reactivity in the top of this activity series, isn't it? Potassium, sodium, calcium, magnesium, aluminium. Okay, so these are the metals of highly reactive metals. And then comes the metal or metals of moderate reactivity, isn't it? Metals of moderate reactivity. Moderate reactivity means which all metals? The zinc, lead, copper, etc. Okay. Then comes the metals of low reactivity. See? So, the metals, according to the reactivity, the metals can be classified as the metals of high reactivity, the metals of moderate reactivity, and the metals of low reactivity. Now, from this flow chart, we can see how we can extract the metal. Okay, I can say metals of high reactivity, you will see electrolysis. You will do electrolysis. You can extract the metal from electrolysis. Why? Because it is highly reactive. You will study later by taking an example. Okay, so simply I am giving a flow chart. So from this you can very well know how you can extract the metals by this reactivity. Okay, the electrolysis and then comes the refining. Okay, just the pure metal you will get. Electrolysis is itself is refining, or you can say simply metal. From the electrolysis of this molten chlorides or fluoride, etc., you can get the metal. Now, coming to the metals of moderately reactive, two types of ores are there here. One is a sulfide ore and other is an carbonate ore. See, one is a sulfide ore and other is a carbonate ore. Now, in the case of sulfide ore, what you have to do? You have to convert the sulfide ore into the oxide ore, isn't it? By, what is the process called? Roasting. Correct? Now, the carbonate ore is also converted to what? The oxide ore. By which process? By calcination. CC. Calcination and carbonate ore. Now, once you get the oxide ore, then what you will do? You will reduce, isn't it? The reduction of metal. Isn't it? You reduce the fourth step. Now, once you reduce, then what you will do? Purification. Isn't it? The last step, that is refining or purification. Correct? So, these are the steps in which the metals of moderately reactive metals happens. Normally, sulfide ores and carbonate ores are there in moderate reactive. Moderate reactive means alzil. Aluminium is coming under high reactivity. Zil, zinc, then iron, then lead, then like that. Okay, these are all comes in this sulfide as well as carbonate. For example, zinc carbonate, then lead sulfide, etc. Clear? Now coming to metals of low reactivity. Normally the metals of low reactivity are seen in sulfide ores, or they are seen as sulfide ores. For example, HGS or copper, Cu2S. So these are all metals of low reactivity. High reactivity means the first topmost, sodium, then potassium, then aluminium, then magnesium. All these are metals of high reactive metals. Metals of low reactive, moderate reactive means zinc, iron, lead, etc. In between also there is low, for example, manganese, isn't it? All comes under this reactivity. Okay, moderate reactivity. Now, metals of low reactivity normally of mercury, copper, etc., they will seen as what? Sulfide ores. Now, you know what happens to sulfide ores, what you have to do for extraction in case of a sulfide ore. You have to first convert it into oxide ore. How? You know, by means of roasting, isn't it? By means of roasting. Here also if you want, you can write roasting for a clear picture. Here also you can write what? Calcination. Okay. Now once you see the flow chart, you will get a full idea of how you extract a metal from the ore. Correct. Now once the oxide ore is there, you know the remaining same. That is the reduction of the metal. Isn't it? The reduction of the metal and then purification, or simply we say refining. Same, both are same. So refining of the metal. Okay. So this is the flow chart concerned with the extraction of the metals. Is it clear? You go through the textbook, it is there. Okay, any doubt, you tell me, I will clear for you. Okay, so next class, I will talk about one by one. We will take one or two examples of each case. Metals of high reactivity, one or two case. Metals of moderate reactivity, one or two case if you take zinc or manganese. And low reactivity also, we will take two cases like copper and mercury, and you will have a detailed discussion of that. Hope you understood this. And one more thing I want to clarify in the last class. You got this? Okay? Correct? Understood? Okay. Read the textbook very thoroughly. Okay. Now one clarification in the last class is just because while talking about the electron dot structure, okay, electron dot structure, I have drawn a structure of sodium. If you are remembering the last class, check out for the last class. The sodium, I have drawn it as Na11 with this nucleus with the 281. Okay. Then I told this is the electron dot structure. Actually, this is the electronic structure. Make it clear. This is electronic structure of sodium element, which we studied in 9th standard. And what is electron dot structure? Specifically, the electron dot structure is, okay, electron dot structure is the formation, what you studied in the formation of ionic compounds. Isn't it? In the formation of ionic compounds, the structure you have drawing there is what is called as the electron dot structure, and the element what you call it as the electronic structure. For example, in the formation of ionic compound NaCl, you call it as Na and Cl 2, 4, 6, 7. See, this is the dot. So this is just clarified. So this is the electron dot structure, and this is the electronic. Electronic means 2. First shell 2, second shell 8, 1, 2, 3, 4, 5, 6, 7, 8. Last shell 1. So make it clear. This is the electron dot structure, and this is the electronic structure. Hope you understood. Just go through the textbook, read thoroughly. So that's all. Till then, keep studying. Thank you.